So very good morning and welcome to class 10 chemistry online class. Now we are continuing with part 5 from the lesson, that is acid, bases and salt. So this is going to be the last part of the lesson, and this is most important, and in CBSE board exams many questions have come repeatedly from this part. So this part carries how salt has been used, sodium chloride salt has been used to synthesize, to produce bleaching powder, baking soda, washing soda, plaster of Paris and gypsum. So this is going to be most important part. I think I can assure you that any one of the preparations will be asked in the board examination. So every year they ask any one of the salt repeatedly. So better concentrate very carefully and learn as much as possible, and it is very simple. Only 5 equations and 5 preparations, and what are the uses of those salt. So that is what we are going to discuss. Let us see what we have learned in the last class. So in the last class we just learned about the uses of the pH, that is a pH activity, and we saw how neutralization reaction has been useful in making antacid, and how do we reduce the stomach acidity, and these are all the points that we have discussed. And we also saw that the most common antacid what is used is magnesium hydroxide. A common name is also called as a milk of magnesia. And we also saw that baking soda can also be one of the antacid what is available in the houses. And why toothpaste are basic in nature? Then we came to know that in the mouth acid is produced due to the microbial activity. To neutralize the acid present in the mouth, it is used by the toothpaste. So toothpaste are basic in nature. And we analyze the pH of the soil has become acidic. So to neutralize the acidic soil, it has been treated with limestone. Limestone is nothing but calcium oxide. It is a kind of a base. When the soil becomes more basic in nature, it is neutralized by using the organic manure like cow dung and other organic manure. This organic manure consists of organic acid. With the help of that organic acid, they neutralize the basicity of the soil. So this is how neutralization reactions are useful even in the agricultural field. Then we saw the effect of insect bite. When the insect bite us, they inject the acid called as formic acid. This formic acid is neutralized by applying baking soda or calamine lotion. So the baking soda, sodium hydrogen carbonate or sodium bicarbonate, that is the base which act against the formic acid what is injected into the skin. Then calamine lotion. So calamine lotion is also consists of a base. We call that is as a zinc carbonate. So these are all the various applications of neutralization reactions. So just understand how these neutralization reactions are very useful in our day-to-day life. Then we saw the final use of that chlor-alkali process. So chlor-alkali process, what is this process? A normal salt solution, that is NaCl. So when the NaCl and it undergoes electrolytic decomposition, it produces the sodium hydroxide, chlorine gas and then the hydrogen gas. So these are all the various applications of that chlor-alkali process. By using this chlor-alkali process, we obtain the byproduct. That is a product what is obtained is called a sodium hydroxide, and we have the chlorine gas and we have the hydrogen gas. And how this sodium hydroxide has been used? So sodium hydroxide, it is a base. So by using the sodium hydroxide, how to synthesize the baking soda? So chlorine gas has been used to synthesize the bleaching powder, and hydrogen gas has been used as a fuel. So these are all the various uses of this sodium hydroxide, chlorine gas and hydrogen gas. Today's class we are going to see so how this chlor-alkali process has been used as the important raw material process to synthesize 5 different salt. So 5 different chemical compounds commonly called as, the first one is bleaching powder. We are going to see how bleaching powder has been used. Then second thing is that baking soda, so how to make baking soda. And third thing is that washing soda. And then fourth one is plaster of Paris, and fifth one is gypsum. So this 5 salt has been taken for the discussion for today's online class. Okay, so when you say about the first, let us take bleaching powder. So we all know bleaching powder, it is a common term. If you see the chemical formula of this bleaching powder, it is written as CaCaOCl2. So Ca stands for calcium, O stands for oxygen, Cl stands for chlorine. So it is called as calcium oxychloride. That is the chemical name of bleaching powder. So let us see how this bleaching powder has to be prepared. What is the chemical reaction that is carried out to form the bleaching powder? The first thing is that the bleaching powder is produced by the action of chlorine. So the chlorine is obtained from the chloralkali process on a dry slaked lime. So slaked lime is nothing but it is a calcium hydroxide solution. Very simple. Pass the chlorine gas to the calcium hydroxide solution. Then this will turn into calcium oxychloride and also helps in the formation of water. So this is the equations to be written for the synthesis of a bleaching powder. So calcium hydroxide CaOH twice is reacted with chlorine gas to form calcium oxychloride and then the water. So this is the common method to obtain the bleaching powder with the help of the chemicals. So one is chlorine gas and another one is slaked lime. It's also called as calcium hydroxide solution. So the lime water is added with the chlorine to form calcium oxychloride and then the water. So this is how a bleaching powder is obtained, and I will show you the video how it is done industrially, how they do this bleaching powder synthesis. So they have taken in the large column. You will have a cylindrical column. So from top of that they pass the chlorine gas, and calcium hydroxide solution will be sprayed inside the tank. So with the help of chlorine vapor and then the calcium hydroxide solutions, they mix together, it produces the compound called bleaching powder, calcium oxychloride. So this calcium oxychloride further it will be dried out and it will be converted into a powder form. So that is how the bleaching powder has been obtained in the industrial process. So I come up with a small video. It is available in the YouTube. You can watch it anytime. So I will show you how this bleaching powder has been manufactured in the industry. Let us watch this video.
For Batman's process, dry slaked lime is used as a raw material which is fed into the tower from the hopper at the top.
So this is a slaked lime that is sprayed on the top of the
A current of
slaker.
chlorine gas is also provided at the same time from an inlet at the bottom of the tower. As the shelves inside the plant rotate, they take the dry slaked lime downwards. During this downward movement, the dry slaked lime comes into contact with chlorine gas, which is moving from bottom to top. The dry slaked lime, which is chemically calcium hydroxide, then chemically reacts with chlorine gas and forms bleaching powder and water. The bleaching powder is then collected in the barrel placed at the base of the tower. To remove water, which is the byproduct of the reaction, a current of hot air is introduced in the tower through the other inlet. The hot air drives away the water as vapor along with unreacted chlorine from the outlet at the top of the tower.
I think you would have been understand in a better way how this bleaching powder has been synthesized in a industry. So that is what the bleaching powder synthesis. So very simple. And the next thing is that we are going to see how this bleaching powder has been used in our life. I think you all know it is a bleaching. The term indicates bleach. So it is used in the textile industry for bleaching cotton and linen, and it also used in the paper industries for bleaching washed cloth in the laundry. So these are all the various uses of bleaching powder. And the second thing is that it is used as an oxidizing agent. In the first lesson we already saw what is an oxidizing agent. It means that the chemical substance that delivers the oxygen in the chemical reaction is called as oxidizing agent. In case of bleaching powder, we just saw that the formula is calcium oxychloride. It is CaO and then the Cl2. There is the presence of one oxygen molecule in the bleaching powder. This oxygen molecule, it is not very tightly bound with the calcium and then the chlorine. So it is very easy to remove this oxygen. So that is the reason bleaching powder is acting as a oxidizing agent in a chemical industries or in the chemical reactions. That is the meaning for oxidizing agent. Hope you are understanding it. The third one is to make drinking water free from the germs. So they have the ability to disinfect the microbe present in the water. So it is also used as a disinfectant. And one more thing you need to understand, in the swimming pool they use only the chlorine powder, not the bleaching powder. Okay, so please make a better understanding. So chlorine already has the ability of acting as a disinfectant. So this is only the pure chlorine has been used to purify the water that is used in the swimming pool. So these are all the various uses of a bleaching powder. Very simple. So once again, I just say how this bleaching powder has been prepared. The chlorine gas has been passed through the Slackert line. It is a calcium hydroxide. CaOH twice is the formula. Then they both react together, undergoes a chemical change to form a calcium oxychloride, which is called as a bleaching powder. So that is how bleaching powder has been synthesized. So we have completed with the bleaching powder. The second salt is most important because it is used in cooking process, baking process, and wherever the carbon dioxide gas is produced in food industry, food manufacturing, they definitely use baking soda. So what is baking soda? The baking soda, chemically it is called as sodium hydrogen carbonate, NaHCO3. So it is also called as sodium bicarbonate. Both are same only. So either it can be called as sodium hydrogen carbonate or sodium bicarbonate. Both are same only. So this is a chemical formula of baking soda. So first thing, how to prepare this baking soda? So this baking soda has been prepared by passing. So first we are going to take a salt solutions. It is a NaCl. Okay, it is aqueous solution, and there is also added with the water. So aqueous means it indicates the presence of water content, and it is passed two different gases. So one is carbon dioxide gas, of course it is a colorless and odorless. The third thing is that it is also added with ammonia. So NH3 stands for ammonia. So ammonia is a mild gas, but this gas is basic in nature. Okay, ammonia is a gas, but this gas is basic in nature. I think in ninth standard you would have been learned about ammonium. There is a difference between ammonia and ammonium. So okay, make a very clear understanding. So ammonia is NH3, ammonium is NH4. So only one hydrogen makes the difference between that ammonia and ammonium. So ammonia, we know that it is NH3. It is a gas. Again, I repeat, it is basic in nature. And ammonium. So when you write ammonium, it is NH4 plus. Okay, one hydrogen is added, etc. One extra hydrogen is added over here. Then we write it as ammonium. So ammonium is NH4 plus. So there is a difference between ammonia and ammonium. So what is the reactant? What are the reactant which has been used to prepare this baking soda? So one is sodium chloride, water content, carbon dioxide gas, and ammonia gas. So these four reactant, when they have been added together, they are going to produce ammonium chloride. So it is a salt. So this is the basic salt. It produces the salt called as ammonium chloride, and of course, so it is also produces the baking soda, that is NaHCO3. So this ammonium chloride can be separated by using the sublimation process. So when you sublimate these mixtures of ammonium chloride and sodium bicarbonate can be separated and it is used as a baking soda. So this is the method, a simple method how baking soda has been prepared. I just repeat it. Baking soda, it is a sodium bicarbonate with the formula NaCO3. It is prepared by adding the salt to the water content, and two different gases is passed through the aqueous solution of salt. So carbon dioxide gas and ammonia. When all these reactants react together, they produce a salt ammonium chloride and also sodium bicarbonate. Sodium bicarbonate, it is a salt. So this salt is also a basic salt. So which is also used as a antacid. Okay, so this is how a baking soda has been prepared. Let us see how this baking soda has been used. So the first is to prepare the baking powder. So what is the difference between this baking soda and baking powder? There is a difference. Baking soda, when it is added with the edible acid like tartaric acid, citric acid, oxalic acid, malic acid, malonic acid, natural acids. So when this baking soda, especially when it is added with the edible acid such as tartaric acid, this tartaric acid is available in the tamarind. So baking soda, when it is added with the tartaric acid, baking soda will turn into baking powder. So this baking powder only often used in the baking process. So there is a difference between baking soda and baking powder. So baking soda, it's a simple salt, sodium hydrogen carbonate. What is baking powder? This baking soda, when it is added with the edible acid such as tartaric acid, it is becoming the baking powder. So that baking powder is heated or mixed with water in the following reaction takes place. So NaHCO3 plus H plus. So this is how we can represent baking powder. When you write baking soda, you can just write NaHCO3. When you write baking powder, it is added H plus. I did not write complete chemical formula of tartaric acid. Okay, it is very complicated. You will learn in the higher classes. So that is the reason I have just added H plus. So H plus indicates the presence of an acid. So edible acid. So NaHCO3 plus H plus combined together, then they become the baking powder. So this baking powder, when it is used with along with the food item, what is the reaction is taking place? This baking powder will decompose. It releases the carbon dioxide gas, water, and sodium salt of acid. This carbon dioxide gas only is called as baking process, makes the food item to be very soft, and that fermentation, at the end of the fermentation you will get the bumpness of cake. So all those things because of the release of carbon dioxide gas. So this is how a baking powder works when it is used as a food items. So carbon dioxide gas produced during the reaction can cause bread or cake to rise, making them soft and the spongy. So this is how the baking soda has been used. So the first use of baking soda is to prepare baking powder. So baking powder is nothing but baking soda when it is mixed with the edible acid, tartaric acid. That is what the difference between baking soda and the baking powder. The next one is the baking soda is also used as an antacid. This point we already discussed when we have been discussing about neutralization reaction also. So when you say about antacid, so sodium hydrogen carbonate is an ingredient in the antacid. So since it is alkaline in nature, alkaline means basic in nature. It neutralizes the excess acid that is present in the stomach. So baking soda can also be used as an antacid. We also saw that magnesium hydroxide, milk of magnesia, that is also used as an antacid, and baking soda also can be used as an antacid. So that is the second use of that baking soda. Then third point is it is used in the fire extinguisher. So we all know there are three types of fire extinguisher. If you look at the fire extinguisher, it would have been given the label A, capital B, and capital C. So capital A only is called as soda acid fire extinguisher. That capital C represents only dry ice. So it will give only the dry carbon dioxide gas. So in the soda acid fire extinguisher, they use the baking soda. So how does it work? In the fire extinguisher, the middle of the container consists of this baking soda. And around that baking soda, they have the acid. Glass, in the glass it is added with acid. So once if you hit the knob on the top knob of the fire extinguisher, it will broken down the acid. This acid will mix with the baking soda, and we know what will happen. It will produce enormous amount of carbon dioxide gas. A very huge amount of carbon dioxide gas will try to come out of that fire extinguisher. That is the reason it is called as soda acid fire extinguisher. Soda represents baking soda, acid represents a citric acid. Okay, so that is how it is used as a fire extinguisher. So these are all the uses of baking soda. The next one, so we have completed the two salt. Okay, the first one is bleaching powder, then the second one is baking soda, then third one now we are moving with washing soda. So this washing soda can be chemically called as sodium carbonate. The formula has been written as Na2CO3 dot 10H2O. I think you need to understand what is this 10 dot H2O. What makes the difference? Yes, these kind of salt are called as hydrated salt. It means there is presence of water content in those salt. Okay, remember this salt has a small amount of water presented in them. So this kind of salt are called as hydrated salt. It means a small amount of water content present in them in order to make them to be a salt, that powder form. It is available. So Na2CO3 dot 10H2O. So sodium carbonate. Na stands for sodium, stands for carbon, O stands for oxygen. So washing soda chemically called as sodium carbonate Na2CO3 dot 10H2O can also be called as this 10. Chemically, the 10 number as value, this value has been given as deca. Okay, 10 is called as like deca, just like your mathematical number, very simple. Okay, so the 10 is called as a deca. So sodium carbonate decahydrate. The name of washing soda can also be written as sodium carbonate decahydrate. Please make note of this point. So that is the chemical formula of washing soda. Washing soda is Na2CO3 dot 10H2O, can also be called as sodium carbonate decahydrate. So how it is obtained? Very simple. It is obtained from the baking soda. So if you just heat the baking soda, you will able to obtain this sodium carbonate. We all know the baking soda has a formula NaHCO3. The thermolytic, you are just increasing the temperature to the baking soda mixture. So it results in the formation of sodium carbonate, that is Na2CO3. Of course, it also releases small amount of carbon dioxide gas and water. Once if you obtain this sodium carbonate, a particular amount of water molecule has been added. So this process is called as recrystallization. I think in the junior class you would have been learned about the crystallization process. During crystallization, the salt is obtained from impure salt by evaporating the water content. Such process is called as crystallization, where there is complete removal of water molecule from the salt. But there are some salt, we call them as hydrated salt. These kind of an salt has been converted into crystal by adding small amount of water molecule. So similarly, washing soda is also added with 10 molecule of water. That means 1 molecule of sodium carbonate is added with 10 water molecule. So it is 1 is to 10 ratio. So 1 is to 10. So each 1 molecule of this sodium carbonate is added with 10 water molecule to get the washing soda, that is Na2CO3 dot 10H2O. So this is called sodium carbonate decahydrate. That is how the washing soda has been prepared. And we all know the term itself indicates washing soda. So this is the powder which is used in most of the washing mixtures. Okay. So that is how sodium carbonate has been obtained. So what are the different uses of this washing soda? So sodium carbonate, okay, so sodium carbonate decahydrate. It is used in glass, soap, and paper industries. It is used in the manufacture of sodium compounds such as borax powder. I think you all know about this borax powder. It is very common, that is available in the medical shops. Okay, immediately when you get injured, they add this borax powder also. Sodium carbonate can be used as a cleaning agent for domestic purpose. It is used to removing permanent hardness of water. I will make it very clear understanding. What is the hardness of water? Is the water can be a hard? Can it be a soft? Or the water itself, it is a liquid. How can it be hard? How can it be soft? These are all the questions that you may get in your mind. There is a reason why we call certain water as hard water. For example, consider the seawater. The seawater consists of most of the salt content in it. That water cannot be used for the washing purpose or for cleaning purpose. When there is more amount of salt present in a water is called as hard water. So it increases the density of water also. So that is the meaning of hard water. Then what is the soft water? When you say about the soft water do not contain much salt content. There is no impurities present in the water. Those waters are called as soft water. Can you give example for this soft water? Very simple. Rainwater, tap water, and the groundwater. What is available? What we use in our life, in our day-to-day activities, is soft water. Yes.
So distilled water.
Distilled water also is a soft water. Okay, so when you say about the hard water and soft water, make a very clear understanding. If you say hard water, it consists of salt content and more amount of impurities. That is the meaning of hardness of water. And when you say soft water, less impurities has been present. Even I think the groundwater, what is available in your house, is also consists of some amount of salt. That is the reason when you boil the water, and you will able to get white color substance that is getting deposited around the vessel in which the water is getting boiled up. So that indicates the hardness of water. So what they do in the sense, they add this washing soda to the groundwater to remove the salt content. So how this washing soda removes salt present in the water? You may ask a question. Washing soda itself, one salt, how it is going to remove the salt present in the water? What is the role of this washing soda? In the sense, when the washing soda enter into the water molecule, it pull down all the salt content present in the water, and they get deposited at the ground level. So above that level you will get the soft water. So that is how washing soda has been used to remove the hardness of water. Please understand it. So when you add washing soda, it is going to pull down all the salt content present in the water, and they are going to be deposited at the bottom of the groundwater. So the top water what is available will be the soft water. So all the salt will be sedimented at the ground level. So that is how washing soda can be used to reduce the permanent hardness of water. Even the filter what you are using in your day to day in your houses, like RO water and some other purifier, will have this process. Definitely it is going to filter the salt content from the water, and it is going to give you the a mineral water that can be used for drinking purpose. So this is how the washing soda can be used. Now, let us see what is the water content present in it. I think I said about recrystallization process, and we also see water of crystallization. So, in the crystallization, we all know that salt will be there, it loses the water content and they turn into a crystal. That is how we saw the crystallization. So, water of crystallization meaning there is some amount of water molecule will be added to the salt to make them crystal. I think copper sulfate is the best example. In the last class, I have shown how this copper sulfate decomposes. So around the test tube, some water bubbles has been observed. So that shows that this kind of an salt will have certain kind of water molecule present in them, but they are not moisture. Okay, they will be crystals only, but the water molecule will be hidden inside that salt. So such a process only is called as water of crystallization. How it can be defined? So water crystallization is the fixed number of water molecule present in one formula unit of a salt. It means for one molecule of salt, how many water molecule is added? That is always called as a water of crystallization. I have given few examples for this water of crystallization. Copper sulfate, CuSO4. So copper sulfate, it consists of 5 water molecule. Okay. Then ferrous sulfate, FeSO4, that consists of 7 water molecule. Then gypsum, so it is a salt. Gypsum is nothing but it is a cement. So CaSO4, it consists of 2 water molecule. And you can see the plaster of Paris, it consists of half a water molecule. You can ask me, the molecule can it be half? I will make it very clear. It is not a half a molecule is not possible. It means that one calcium sulfate, that is one CaSO4, okay, one CaSO4 and one water molecule, okay, one water molecule will be there, that is a H2O, okay, and one more calcium sulfate, one more CaSO4, okay. So when they combine two molecule of calcium sulfate will be combining with one water molecule. Please understand this. Okay, one calcium sulfate, one CaSO4, two CaSO4, two molecule of calcium sulfate will be combining with one molecule of water. So when you write for one molecule of calcium sulfate, it becomes half of the water molecule. So one water molecule is enough to share the water content with calcium sulfate. So when you write chemically for the mathematical understanding, we are just writing as 1 by 2 H2O. Okay. So one plaster of Paris, it is requires half of the water molecule. Washing soda Na2CO3 dot 10 H2O. So these are all that gives the clear indications that there are the salt which consist of water molecule present in them. So this process is called as water of crystallization, or can also be called as recrystallization. So that is the meaning of the recrystallization process. So once if you heat this kind of a salt, they have the ability to lose the water content. I think I will show you with one of the copper sulfate. This activity you would have been also done in the class 9, that shows the physical changes. So in the test tube they have taken the copper sulfate, it is a blue color salt, and if you provide the heat energy, copper sulfate will be there. Yes, then copper sulfate is a light color salt. Once you heat the copper sulfate, you will get this white color like this is the water content. Same thing. One molecule of copper sulfate is added by water molecule. That is the reason why this CuO not by H2O belongs to the basis of water. When you heat the copper sulfate, this is red color surface. So this is completely changed. This is completely changed because copper sulfate retains its copper sulfate only change color is making this because this is the water content. Okay, CuSO4 dot 5H2O is becoming CuSO4 dot plus 5H2O. That shows water molecule has been removed. And if you cool down the test tube, just wait for some more time, just cool down the test tube and then try to add the water to the test tube. I think one side it has turned into white color, another side still the heat energy is not sufficient. Now add a small amount of water to it, again you can get back the blue color of the copper sulfate. So very simple process. So this is what we call as a water of crystallization. Okay, then we come to the fourth salt. It is nothing but plaster of Paris. You can ask me why the name has been given plaster of Paris. Before that we'll see what is the chemical name of this plaster of Paris. So calcium sulfate, CaSO4. So Ca stands for calcium, S stands for sulfur, and O stands for oxygen. So this salt can also be called as calcium sulfate hemihydrate. I think they have mentioned over here. The chemical name of plaster of Paris is nothing but calcium sulfate hemihydrate, which is known as plaster of Paris with the chemical formula CaSO4 dot of H2O. So let us come back. Why this plaster of Paris? Is it available only in the Paris, or does the name has been given like that? Yes, there is a reason why this plaster of Paris. So in the Paris, of course, it is first obtained in the Paris, in the mountain. They observed the gypsum salt. Okay, it was in the mountain rock, they have taken the gypsum salt. This gypsum salt, when it's get heated up, when you just raise the temperature salt, they decompose and it has given the calcium sulfate hemihydrate. Then this salt has been used for the construction purpose. They started to construct by using the plaster of Paris. So since it is obtained in the mountains of class Paris and also used burning, gypsum, and it is burned to release the calcium sulfate hemihydrate. The name has been given as a plaster of Paris. I think you can, if you want to know further, you can always Google it up. So plaster of Paris, calcium sulfate hemihydrate, that is a chemical salt. How it is obtained? When it is gypsum, CaSO4, That is, this reaction is also reversible. Please understand, I am writing in this way. So what is the equation as given for gypsum? So CaSO4, when it is gets heated up by 373 Kelvin temperature, so approximately 100 degrees Celsius. So this salt, when it gets heated up, it is results in the formation of a plaster of Paris, CaSO4 dot half H2O plus 1 and of H2O. So this is how we obtain the plaster of Paris. Similarly, again this plaster of Paris can be converted into gypsum by adding 1 and of water molecule. Okay, that is how the plaster of Paris converted into gypsum, and gypsum is also converted into plaster of Paris. In the cement, what is used in the construction purpose, it always comes in the airtight container. There is a reason, because it also consists of this plaster of Paris. So this molecule, once it is open to the atmosphere, they absorb the moisture present in the atmosphere and they turn into a hardest substance. That is the reason after constructing the new building that they always try to pour the water. How much amount of water is added to it, it strengthens, it increases the hardness of that cement material. Okay, that is a reason. Okay, so remember, so plaster of Paris can be obtained from gypsum. When the gypsum salt, when it is heated up around 373 Kelvin temperature, approximately 100 degrees Celsius, the gypsum can be converted into plaster of Paris, CaSO4 dot half H2O plus 1 and of H2O. Again, this plaster of Paris, by adding water, they turn into gypsum. I think you all know the uses of this plaster of Paris. So the plaster of Paris powder, when it is added with the water content, they become the solution. Immediately, if it gets dried up, they become very hard. So this is used to make a toys, interior designing, and in the medicinal they use for binding the bones, all those things, as becomes the plaster of Paris. So this plaster of Paris, CaSO4 dot of H2O, it is used for producing the mold for pottery and ceramics and causes of statues and bursts. It is also used in surgical bandages, used for plastering broken or fractured bone. So it is also used in the dentistry. So these are all the different uses of a plaster of Paris. Then preparing the gypsum from POP. As I said, this plaster of Paris is added with 1 and of water molecule and it is turning into a gypsum, that is CaSO4 dot 2H2O. Very simple. So that is what we have discussed. So you people learn these 5 equations with the uses. I am assure you that any one of the questions will be asked in your board exams. So this is the most important part of the second lesson. Okay. So with that, we are completing our lesson acid, bases, and salt. Okay. So let us recall what you have learned today. So today we just learned how to synthesize these 5 kind of chemical salts. So one is bleaching powder. So with the formula calcium oxychloride. Then second one is baking soda, sodium hydrogen carbonate. We also saw baking powder. So baking soda is added to the edible acid is called as baking powder. Then third one is washing soda, that is Na2CO3.10H2O. And fourth one is plaster of Paris, CaSO4.H2O, and gypsum, that is CaSO4.2H2O. So thank you. We are completing the acid, bases, and salt. By this, we are completed the 2 lessons. Okay. Now we'll get back to the questioning sessions. So learn these 5 equations with the users, and it is very simple. If you practice these equations, then it is easy to understand. So please understand all these equations. Okay. So right now we have 52 attendees, and who are the absentees? May I know the absentees?